We can now take a look at a more general situation. The point of application of the 50-pound force is still at point B, but the line of action of the force is rotated clockwise. The angle of rotation is such that the line of action of the force forms a 3, 4, 5 triangle with the xy coordinate axes. Once again, we would like to calculate the moment that this force produces about point A. We will begin our solution process by first determining the xy components of the force vector. Since we are working with a 3, 4, 5 triangle, these components can be readily determined to be a 40-pound force in the positive y direction and a 30-pound force in the positive x direction. This pair of Cartesian vectors forms an equivalent force system that can now be used to replace the original 50-pound force. The next step in the process is to determine the moment arm of each of these forces with respect to point A. As previously discussed, the sign convention used in the scalar formulation of a moment defines counterclockwise moments as positive and clockwise moments as negative. The moment arm is defined as the perpendicular distance between the line of action of the force and a parallel axis that passes through point A. Using this definition, the 40-pound force can be seen to have a moment arm of 5 feet. This force moment arm configuration results in a counterclockwise moment about point A. The magnitude of this moment is the product of the 40-pound force times the 5-foot moment arm. Now turning our attention to the 30-pound force, we see that the line of action of this force not only passes through point B, but also passes through point A. Again, using our definition of the moment arm, we determine that the moment arm of the 30-pound force with respect to point A is 0, and thus we conclude that the 30-pound force does not contribute to the moment about point A. We can include this information in our equation by writing that the moment of this force is equal to the magnitude of the force times a moment arm of 0. By evaluating the expression, we then determine that the total moment about point A due to the 50-pound force passing through point B is 200 foot-pounds.